Hello students, welcome back to Pharmaceutics 1, Unit 4, Pharmaceutical Incompatibilities Part B. In the previous lecture, we have seen what are the various contents of incompatibility. In that we have defined what is incompatibility. Incompatibility is defined as mixing of two or more antagonistic substances which leads to an undesirable product, which will affect the safety, efficacy and appearance. And we have seen it may be with drug and drug when they are combined, or drug when combined with additives that are used in the pharmaceutical formulations. Now, in the previous video, we have discussed about physical incompatibility. Now, let us discuss about chemical incompatibilities. What is a chemical incompatibility? A chemical incompatibility is the one where there is an interaction between the ingredients of a prescription leading to toxic product. What is a chemical incompatibility? An interaction between the ingredients like drug and the drug present in the prescription, or drug with another drug which has some excipients with that or additives. So it is the interaction between the ingredients of a prescription which leads to toxic product and which is not desirable. Now, why it occurs? It occurs due to oxidation reduction reaction taking place in that particular prescribed drugs, or acid base hydrolysis, or a combination of reactions. Now, how do we notice the chemical incompatibility? How do you observe that there is a chemical incompatibility? Chemical incompatibilities are noticed by a change in the product. What are the changes you observe? What do you notice? Number one, a precipitation of the product is seen. Maybe a white colored product is formed or a yellow colored product. Any precipitate is formed. Or there may be some effervescence seen in the product. Effervescence is nothing but release of carbon dioxide. Or we may notice a decomposition of the product. Decomposition. Initially the product is white in color when we started using, but after one day or after preparation, the next day we see that its color has been changed. Decomposition. Decomposition is nothing but where the stability of the product is changed. Okay, a reaction is taking place, or a color change in the product, or an explosion in the product. A product may explode. So these are the types how we are going to notice that the chemical incompatibility has taken place. That is, number one, there may be a precipitation of the product. Number two, effervescence are seen. Number three, decomposition of the product is there. And four, we see a color change. Or fifth, it may be an explosion of the product. Now let us go in detail into the chemical incompatibilities, which is one of the incompatibility which need to be discussed in detail. Now these chemical incompatibilities are two types: tolerated chemical incompatibility and adjusted chemical incompatibility. Tolerated means, as the name itself indicates, yes, we can tolerate the reaction. Okay. Now this particular tolerated incompatibility, we can say the chemical interaction can be minimized within the product by a change in the order of mixing. So we need to change the order of mixing. Instead of adding a drug A to drug B and then C, we can change the order. Maybe initially we take the drug C, to that you add a drug B and then A, mix it, then add your excipients, like that. So a change in order of mixing, but no alteration of ingredients is required here. This is called as tolerated incompatibility. Tolerated, the chemical interaction can be minimized by a change in order of mixing, but no alteration of ingredients is required. Number two, adjusted chemical incompatibility. The interaction here, it can be prevented. How we can prevent? By addition or substitution of one of the ingredients. In the adjusted, what we are going to do? We will add or substitute one of the ingredients of that particular product. Now, this adjusted incompatibilities is of two types. Intentional, unintentional. Intentional means knowingly the prescriber prescribes the drugs which are incompatible. Or unintentional, without his knowledge, without the knowledge of incompatibility of drugs, he is prescribing the medicines there. That is what is called as unintentional. Now, this particular chemical interaction, especially the precipitate is going to formed. As I said, precipitate is formed. When the precipitate is formed? Because when two of the reactants react in a very faster rate, the precipitate is formed. So reaction between strong solution proceed at a faster rate and the precipitate is formed at a faster rate. And whatever the precipitate that is formed, it is of two types: diffusible precipitate, indiffusible precipitate. So there are two methods that are used to dispense this diffusible and indiffusible precipitate. Method A, method B. What are the two methods used for dispensing the diffusible and indiffusible precipitates? Method A and method B. Now what is method A? In method A is very simple. Divide the vehicle. Vehicle is nothing but the solvent system. It may be a water or a syrup based system, or it may be an organic based system, but generally we prefer a syrup based systems in case of the syrups. And aqueous systems, that is water. So divide that particular vehicle which is water into two equal parts. Dissolve one of the reacting substance in one part. Okay, so say for example you have the product A. Two reactants we have A and B. So divide your vehicle into two parts. Take two beakers. Divide, add your vehicle here and vehicle B in two beakers. Add A into beaker 1. Add B drug into beaker 2. Then slowly you mix this A to the B slowly. Okay, so this is about the method A. Divide the vehicle into two parts. Dissolve one of the reacting substance in one of the portion. Add the other substance in the other. Mix the two portions slowly and add one portion to other slowly and then rapidly mix. Now method B. Now method B is also very simple, which is used for indiffusible precipitate. Here also we divide the vehicle into two parts. Okay. Now here if you see the steps, what we are going to do in this particular indiffusible precipitate method B. Here also I divide the vehicle into two parts. Take that vehicle into two beakers. This is the vehicle where I am going to add the drug A. This is beaker A containing one portion of the solvent system. Now this is beaker B containing the solvent system. Now to this beaker B, what I am going to do, I am going to add a suitable quantity of tragacanth powder into this and make a smooth paste here, smooth mucilage. Then I am going to take my drug B and then add it into the beaker B. Then mix uniformly. Now later after mixing, now take the contents of the beaker A containing the drug and add it to the beaker B containing the tragacanth plus the drug which was made as a smooth mucilage. Add slowly and then finally mix rapidly. So for such type of things, what is the label we need to write? We should write it as shake well before use. Shake well before use is the title which we need to write. Very simple method. Divide the vehicle into two parts. That is, take the solvent in beaker A and beaker B. In beaker A, add drug A. In beaker B, in the step 2, add first tragacanth powder, make a smooth mucilage. Then add drug B and mix it. In the third step, okay, add the portion A to the portion B. Now, let us discuss few examples. I will discuss in a very simple way so that it is easy for you to remember. Now here we will see the various examples of alkaloidal incompatibilities. Now here alkaloids are the products, constituents, chemical constituents which are applied, which are obtained from drugs. All these alkaloids, they are obtained from some drugs, plant drugs, which are obtained from plant drugs here. Okay. Now, most of these alkaloids are incompatible. Now you can see with what they are incompatible. We will divide that into 5 types. Number 1. Alkaloid salts which are incompatible with alkaline substances. Now simply call it as alkaloidal salts with alkaline substance. Number 2. Alkaloidal salts with soluble iodides. Number 3. Alkaloidal salts with tannins. Number 4. Alkaloidal salts with salicylates. And the 5th, alkaloidal salts with soluble iodides and bromides. This is very important, guys. So alkaloids, as I said, these are chemical compounds which are obtained from plant drugs. And all these alkaloids are having most of the incompatibilities. So here we are going to discuss major 5 types of alkaloidal incompatibilities. What are these? Alkaloidal salts with alkaline substances, alkaloidal salts with soluble iodides, alkaloidal salts with tannins, alkaloidal salts with salicylates, and 5th one is alkaloidal salts with soluble iodides and bromides. Now, in a simple way, I will discuss each one of the before mentioned slide in a simple diagrammatic way. So what you are supposed to do, you first make 3 columns. Number 1, problem with the alkaloids. Number 2, solution. What are the examples? Now, first one is alkaloidal salt with alkaline substances. Now here you can see any alkaloidal salts when combined with alkaline substances, alkaline preparations like ammonia, ammonium bicarbonate, ammonium sodium bicarbonate, it leads to the formation of a precipitate. I repeat, alkaloidal salts like strychnine, when combined with alkaline preparations like ammonia, ammonium bicarbonate, it forms a precipitate. Now, what is the solution for this? Whatever the precipitate it is formed, it is slightly soluble in water. Okay. So therefore, in simple, what is that? We can select method A or method B. So generally we select a method A. What is the example here? Strychnine hydrochloride in presence of aromatic spirit of ammonia and water. So select method A. Done. Now the second one, alkaloidal salts with soluble iodides. Now you can see what are the various alkaloidal salts like. It may be ipecac, emitin, strychnine. We have a strychnine here, same strychnine you can get it here. Now when these alkaloidal salts with strychnine combine with iodides, it forms a diffusible precipitate. What is the solution we have? Follow simple method A, that is for diffusible precipitates. Example you can see the sodium iodide containing ipecac, which is used in the cough syrup. Now third one, alkaloidal salts with tannins. Tannins are also the products which are obtained from the plants. So when these two are combined, it leads to diffusible precipitate. What is the method we should use? Follow method A. Example, the same example, alkaloidal poisoning with tannic acid. Now, other and the fourth example is salicylates when combined, sodium salicylates when combined with quinine compounds. It forms quinine hydrochloride. Quinine is again nothing, don't get confused. Quinine is nothing but it is an alkaloidal salt. So alkaloidal salts like quinine, when combined with salicylates, it forms indiffusible precipitate. So it is an indiffusible precipitate, follow method B. So along with quinine, what are the other ingredients used in that particular product? Sodium salicylate, water, caffeine citrate. Water. Now, and the last, alkaloids with iodides and bromides. That means alkaloids like strychnine, codeine, morphine, when they combine with iodides and bromides, they form hydroiodides and hydrobromides. I repeat. So, alkaloidal salts like strychnine, codeine, morphine, when combined with iodide and bromides containing products, it forms hydroiodides and hydrobromides. They are insoluble but diffusible, hence used method A. Okay, so this is a simple table which you have to remember. Divide this into the problem, solution and example. Now the same thing here I discussed with 2-3 examples like sodium salicylates with the sodium salicylate incompatibilities, like salicylates, you can see soluble salicylates with ferric salts, it forms indiffusible precipitates, so use method B. So discuss any one of these methods as I explained in the previous slide. Consider as a reactant, problem and what is the solution and example here. In the similar, this is a soluble iodides and very good example and which you have to remember is oxidation of iodides with quinine sulfate. So this is very important. You can see here. What is happening here? This quinine sulfate, it is not soluble in water. So we make it soluble by using dilute sulfuric acid. But for dissolving iodine, we use potassium iodide. We know that. We have done in the practicals also. But here you see, this particular dilute sulfuric acid, it liberates the hydroiodic acid from potassium iodide. At the same time, it is getting oxidized. So therefore, what it is forming? It leads to the formation of hydroiodides and bromides there, hydroiodides. So therefore, now the reaction contains iodine, hydroiodic acid, quinine sulfate. All these things are combined to form what is called as iodosulfite of quinine. What it is going to form? Iodosulfite of quinine, which is called as herapathite. Herapathite. Now, what is the solution? Solution is very simple. Supply only for 3 days. In case mixture is prepared for more than 3 days, solutions are prepared in half volume in water and then supplied in separate bottles. Okay, so this you have to remember, guys. In similar, you need to remember one example of carbon dioxide, evolution of carbon dioxide, effervescence, where sodium bicarbonate when combined with soluble calcium or magnesium salts, it causes double decomposition reaction leading to the formation of insoluble carbonates and carbon dioxide. Use diffusible precipitate, follow method A. Okay, so these are the references books which you can follow, and thank you. And recap once again, we have discussed here chemical incompatibilities. What is chemical incompatibility? Reasons, how it is noticed, and when it is going to form a precipitate, it is of 2 types, diffusible and indiffusible. And what is the method we need to use? Method A for diffusible, method B for indiffusible. And especially we have discussed the various examples of alkaloidal incompatibilities followed by salicylates, tannins, iodides and release with carbon dioxide. Thank you.